We need to find an integrating factor of the differential equation sin x into dy by dx plus 2y cos x is equal to 1. Let us rewrite this equation dividing with sin x on both the sides. So we get dy by dx plus 2y into cos x upon sin x is equal to 1 upon sin x. So dy by dx plus 2 times of cot x into y is equal to cosecant x, which is in the form of dy by dx plus p of x into y is equal to q of x. So it's a linear differential equation, and its integrating factor if is equal to e to the power integral p of x dx. So here we can write here p of x is equal to 2 into cot x and q of x is equal to cosecant x. So we need only integrating factor. So let us write. So integrating factor if is equal to e to the power integral 2 cot x dx, which is equal to e to the power of 2 times integral cot x is log of sin x, which is equal to e to the power log sin square x, because we know the property m times log a is equal to a to the power m. Log a to the power m we can write. And also here the base is considered e, and we know the property e to the power log a to the base e is equal to a. So here we can write the answer as sin square x. So the simplification is sin square x. So we can say integrating factor of this differential equation is option A, sin square x. We need to find the expression which satisfies the differential equation, or we need to find the solution. The expression satisfying means solution. The solution of the differential equation x square minus 1 dy by dx plus 2xy is equal to 1. So we can write x square minus 1 dy by dx plus 2xy is equal to 1. Let us divide with 2 x square minus 1. So we get dy by dx plus 2x upon x square minus 1 into y is equal to 1 upon x square minus 1. So it is in the form of dy by dx plus p of x into y is equal to q of x, linear differential equation, and its integrating factor is e to the power integral p of x dx, and it's a general solution we can write y into integrating factor is equal to integral of q of x into integrating factor dx. So we can write here, first let us find integrating factor. If is equal to e power integral 2x upon x square minus 1 dx, and here we can substitute or put x square minus 1 is equal to t, so that 2x dx is equal to dt. So we can write integral e to the power dt divided by t, that is e to the power log t. And again, by using the properties of logarithms, e to the power of log a to the base e is equal to a. So we can write here the base is e, so we can consider t. So t is nothing but x square minus 1. So it's an integrating factor. So general solution we can write y into integrating factor, that is x square minus 1, is equal to integral of q of x, that is 1 upon x square minus 1, into integrating factor, that is x square minus 1 dx. So here we may cancel x square minus 1. So y into x square minus 1 is equal to integration of 1 dx, which implies y times of x square minus 1 is equal to integral 1 dx is x plus integral constant c. So we can go with an option y times of x square minus 1 is equal to x plus c, which is option C. We need to find the solution of the differential equation dy by dx is equal to cos of x plus y plus sine of x plus y. So here both the trigonometric ratios cos and sine in terms of x plus y. So let us substitute. Put x plus y is equal to t. So the differentiating with respect to x, we get 1 plus dy by dx is equal to dt by dx, or we can get dy by dx is equal to dt by dx minus 1. So let us substitute in the equation. So we get dt by dx minus 1 is equal to cos t plus sin t, or this can also be written dt by dx is equal to 1 plus cos t plus sin t, and we know that 1 plus cos t is 2 cos square t by 2, and sin t formula we can get 2 sin t by 2 into cos t by 2. So we can take common 2 cos square t by 2, so we get 1 plus, and here sin by cos is tan t by 2. So 2 cos square t by 2 we can get 2 times of 1 plus tan t by 2 divided by secant square t by 2, which is equal to dt by dx. Now separating the variables, we can write secant square t by 2 divided by 2 times of 1 plus tan t by 2 dt is equal to 1 dx, and integrating on both the sides. So put 1 plus tan t by 2 is equal to some variable p, which implies differentiation of tan is 2 secant square t by 2 into 1 by 2 dt is equal to dp. So we can write secant square t by 2 into dt is nothing but dp. So integral dp divided by 2 times of p, which is equal to x plus c. So 1 upon 2 integration dp upon p is 1 by 2 log p is equal to x plus c. So we can write 1 by 2 log p is nothing but 1 plus tan t by 2 is equal to x plus c, or we can write 1 by 2 times log 1 plus tan t is nothing but x plus y. So we can write tan of x plus y by 2 is equal to x plus c. Well, let's check here. Differentiation of tan is secant square x. Please let me correct here. Differentiation of tan is secant square x. Sorry here, and again in differentiation of t by 2 is 1 by 2. So we'll be getting only 1 by 2. We cannot cancel this. So 1 by 2 secant square t by 2. So 1 by 2 secant square t by 2. So here secant square t by 2 divided by 2. We can write it as a dp. So there is no 2. So the answer is log of 1 plus tan of x plus y by 2 is equal to x plus c, which is option B. Given that f from 1 comma infinity to 2 comma infinity be a differentiable function such that f of 1 is given 2, and also 6 times integral 1 to x f of t dt is equal to 3x into f of x minus x power 3. So let us differentiate on both the sides. So we get 6 times d by dx of integral 1 to x f of t dt is equal to d by dx of 3x into f of x minus x power 3. And we had a property integral f of x to g of x h of t dt is equal to differentiating d by dx of is equal to, we can write h of g of x into g dash of x minus h of f of x into f dash of x. So that we can write here differentiation of integral. So 6 times f of x, we can write here f of x into differentiation of x is 1 minus f of 1 into differentiation of 1 is 0, which is equal to, and here differentiation UV rule, 3 times x into f dash of x plus 3 times f of x into differentiation of x is 1 minus 3x square. So we can add 6 times f of x is equal to 3 into x into f dash of x and plus 3 times f of x minus 3x square. Or we can also write 6 times f of x minus 3 times f of x is 3 times f of x is equal to 3 into x into f dash of x minus 3x square. So let us substitute or put f of x is equal to y. Let f of x is equal to y. So we can write 3 times y is equal to 3 into x into dy by dx minus 3x square, or this can also be written dividing with 3x, 3y by 3x is equal to 3x dy by dx divided by 3x minus 3x square divided by 3x. So we can write here y upon x is equal to dy by dx minus x, and this can also be written dy by dx minus 1 upon x into y is equal to x. So which is the linear differential equation form. Comparing with dy by dx plus p of x into y is equal to q of x. So p of x is equal to negative 1 upon x and q of x is equal to, we can write x, and its integrating factor e to the power integral p of x dx, which is equal to e to the power integral minus 1 upon x dx, that is e to the power integral minus 1 upon x dx is log x, so we can write minus log x, or we can write e to the power log x to the power minus 1, that is e to the power log 1 upon x. Since the base is same here, so we can use the property and write 1 upon x. So integrating factor is 1 upon x, and general solution we can write y into integrating factor is equal to integral of q of x into integrating factor. So we can write y is nothing but, so y into integrating factor is 1 upon x is equal to integral of q of x is x into 1 upon x dx, that is y upon x is equal to integration of 1 dx is x plus c. that is y is equal to x square plus cx, and it is given that y of f of 1 is equal to 2, that is f of x is equal to x square plus cx here, given f of 1 is equal to 2. So put x is equal to 1, so we'll get 2 is equal to 1 square plus c, that is c is equal to 1. Now when c is equal to 1, so we can write the function f of x is equal to x square plus c into 1 into x. Cx, that is 1 into x, is x. F of x is equal to x square. Therefore f of 2 is equal to 2 square plus 2, that is 4 plus 2, which is equal to 6. So 6 is the answer, option D. Given that pi of x is a differentiable function and the solution of the differential equation dy plus y into pi dash of x minus pi of x into pi dash of x dx is equal to. So dividing with the dx on both the sides, we get dy by dx plus y into pi dash of x minus pi of x into pi dash of x is equal to 0, which can also be written dy by dx plus pi dash of x into y is equal to pi of x into pi dash of x, which is in the form of dy by dx plus p of x into y is equal to q of x. So integrating factor is equal to e to the power integral p of x dx, which is equal to e to the power integral, and here p of x is pi dash of x dx, which is equal to e to the power integral of differentiable function will be pi of x e to the power pi of x. And now the general solution, y into integrating factor is equal to integral of q of x into integrating factor dx. So we can add y into integrating factor is e to the power pi of x is equal to integral of q of x is pi of x into pi dash of x into e to the power of integral, sorry, e to the power of pi of x dx. And now let us assume that e power pi of x into pi dash of x as one function and pi of x is the second function. Let us consider this is first function and this is the second function. So by using the by parts, integral fg is equal to f integral g minus integral of f dash into integral of g. So we can write pi of x into integral of e power pi of x into pi dash of x dx, and again minus integral of differentiation of pi of x is pi dash of x into again integral of e power pi of x into pi dash of x whole dx and again whole dx, which is equal to pi of x into, and here let us substitute or put pi of x is equal to t or e to the power pi of x is equal to t. So we get e to the power of pi of x into pi dash of x dx is equal to dt. So we can write integral of dt minus integral of pi dash of x into, and again this integral is same as dt. So integral of dt is nothing but here t we can write. Let us write one more step, which is equal to pi of x into integration of 1 dt is t. T is nothing but e to the power of pi of x minus integral of pi dash of x into integral of 1 dt is t. T is nothing but again e to the power pi of x. So again further we can write pi of x into e power pi of x minus again the same pi dash of x into e power pi of x is same as integral of dt, that is t, that is e power pi of x. That is y into e to the power of pi of x is equal to pi of x into e power pi of x minus e to the power of pi of x plus constant, or y into e to the power pi of x is equal to e power pi of x taken common, and hence we can write pi of x minus 1 plus c into e to the power minus pi of x. So we may cancel here e power pi of x. So we can write y is equal to pi of x minus 1 plus c into e to the power of minus pi of x, which is our option A. So option A is the answer. We need to find the degree of the differential equation which satisfies the relation root of 1 plus x square plus root of 1 plus y square is equal to lambda times of x root of 1 plus y square minus y root of 1 plus x square. We need to find the degree. So let us simplify by substituting. Put x is equal to tan A, y is equal to tan B, so that under root of 1 plus tan square A plus under root of 1 plus tan square B is equal to lambda times of x times of, that is tan A into root of 1 plus tan square B minus tan B into root of 1 plus tan square A. And we know that secant square theta minus tan square theta is 1. So 1 plus tan square is equal to secant square theta. So we can write root of 1 plus tan square A is secant A plus secant B is equal to lambda times of tan A, you can write sin A divided by cos A into under root of 1 plus tan square B secant B, that is 1 upon cos B, or we can write secant B minus tan B into, so we can write sin B upon cos B into under root of 1 plus tan square is secant A. So secant A we can write 1 upon cos A plus 1 upon cos B is equal to lambda times of sin A into secant B into cos B minus sin B into secant A into cos A divided by cos A cos B, that is cos A plus cos B upon cos A cos B is equal to lambda times of secant B into cos B is 1, because secant theta into cos theta is 1. So secant A into cos A is also 1. So we may write sin A minus sin B upon cos A into cos B. So we may cancel here cos A cos B on both the sides. They cannot be equal to 0. So which implies that cos A plus cos B is equal to lambda times of sin A minus sin B. So cos C plus cos D is 2 cos C plus D by 2 into cos C minus D by 2, that is A minus B by 2, which is equal to lambda times of sin A minus sin B is 2 cos c plus d by 2 into sine of c minus d by 2, that is a minus b by 2. And here we may remove that cos of a plus b by 2 on both the sides and 2 also. So cos of a upon a minus b upon 2 will go other side, so that is tan, or we can write tan of a minus b upon 2, which is equal to 1 upon lambda, which implies a minus b upon 2 is equal to tan inverse of 1 upon lambda, that is a minus b is equal to 2 times of tan inverse 1 upon lambda, where lambda is some constant and lambda is not equals to 0 we consider, and a is nothing but we can write tan inverse of x, because we know that tan x is equal to tan a we consider, so a is equal to tan inverse x we can write. So tan inverse x minus tan inverse y is equal to 2 tan inverse of 1 upon lambda. Now differentiating with respect to x, we get differentiation of tan inverse x is 1 upon 1 plus x square minus 1 upon 1 plus y square into dy by dx is equal to differentiation of this is a constant, so we get 0. So we may write here 1 upon 1 plus x square is equal to 1 upon 1 plus y square into dy by dx, or dy by dx is equal to 1 plus y square upon 1 plus x square, and it's a differential equation whose order is 1 and degree the power is 1. So here we can mention the order is 1 and degree is 1. So you can go with an option A. We need to find the solution of the differential equation x square is equal to 1 plus x upon y whole power minus 1 into dy by dx plus x upon y whole to the power minus 2 into dy by dx whole square upon 2 factorial plus x upon y whole power minus 3 into dy by dx whole power 3 upon 3 factorial and so on. So it is in the form of 1 plus x upon 1 factorial plus x square upon 2 factorial plus x power 3 upon 3 factorial plus and so on is equal to e to the power of x. It's an expansion of the exponential function e power x. So here we can write x square is equal to, and this is e to the power of, and here x is nothing but x upon y whole to the power minus 1 into dy by dx, or this can also be written x square is equal to e to the power y by x into dy by dx, and then we can write log x square is equal to y upon x into dy by dx, and then we can substitute here x into log x square dx is equal to y into dy. It's a variable separable form integrating on both the sides, and here put x square is equal to t, so that we'll get 2x dx is equal to dt. So we can write integral x dx is nothing but 1 upon 2 and log t dt, which is equal to integration of y is nothing but y square upon 2 plus some constant c, and 1 by 2. So we can write here 1 upon 2 integration of log t. Let us simplify. Integration of log t dt, we can write integration of 1 into log t by using the by parts. So let us consider L is the first function and algebraic function is 1 is second function. So log t into integration of 1 dt minus integral of differentiation of log t is 1 upon t into integration of 1 dt. So we can write integration of log t into integration of 1 dt is t, that is t log t minus integral of 1 upon t into integration of 1 dt is t. So we can write t log t minus t plus c. So we can write here 1 upon 2 times integration of log t is t into log t minus t is equal to y square upon 2 plus c, or this can also be simplified 1 upon 2, t is nothing but x square into, or x square taken common, log x square minus 1 is equal to y square upon 2 plus c, or x square into log x square minus 1 is equal to y square plus 2 into c is another constant we can consider 2c. So we can go with an option x square into log x square minus 1, the constant we can take to the other side, so plus c is equal to y square. So we can choose the option A. The general solution of the differential equation dy by dx plus sine of x plus y is equal to sine of x minus y. So we can write dy by dx plus sine of x plus y minus sine of x minus y is equal to 0. And we know that sine a plus b minus sine a minus b, so we can write 2 cos a sine b. So we can write here dy by dx plus 2 cos x into sine y is equal to 0. Now dividing with the sine y, our dy upon dx is equal to minus 2 cos x into sine y. Dy upon sine y is equal to minus 2 cos x into dx. Now it's a variable separable. We can integrate on both the sides. Integral of cosecant y dy is equal to minus integral minus 2 times of integral of cos x dx. Integration of cosecant y is, so we can write log mod of tan y upon 2 is equal to minus 2 integration of cos x is sin x plus c, or we can also write log mod of tan y by 2 plus 2 sin x is equal to c. So we can go with an option B. We need to find the solution of the differential equation dy by dx is equal to y into f dash of x minus y square upon f of x, where f of x is a given function. So this can be simplified as y into f dash of x upon f of x minus y square upon f of x. So dividing with y square on both the sides, 1 upon y square into dy by dx is equal to 1 upon y into f dash of x by f of x minus 1 upon f of x. So put 1 upon y is equal to t. So you'll get minus 1 by y square dy by dx is equal to dt by dx. So we can add 1 upon y square dy by dx is minus dt by dx is equal to, so t into f dash of x upon f of x minus 1 upon f of x. So this can also be written dt by dx plus f dash of x upon f of x into t is equal to 1 upon f of x, which is in the form dy by dx plus p of x into y is equal to q of x. So here integrating factor is equal to e to the power integral p of x dx, which is equal to integral e to the power, here p of x can be taken as f dash of x by f of x dx, which is equal to f dash of x by f of x is nothing but log f of x. We can write integral log of f of x by substituting f of x is equal to t, f dash of x dx is dt. So integral 1 upon t dt is log t. So log f of x, which is equal to f of x, we can write. And the general solution, y into integrating factor is equal to integral of q of x into integrating factor. So from here, but here y is equal to here the two variables t and x. So here we can write t into integrating factor is f of x is equal to integral of q of x is 1 upon f of x into integrating factor is f of x dx. So t is nothing but 1 upon y. So 1 upon y into f of x is equal to integration of 1 dx is, so that is f of x is equal to y into x plus c. So f of x is equal to y times of x plus c, which is option A. The differential equation whose solution is given ax square plus by square is equal to 1, where a and b are arbitrary constants. So we can get ax square plus by square is equal to 1. Let's differentiate with respect to 2x. So we get 2a into x plus 2b into y dy by dx is equal to 0, or we can write ax plus by into dy by dx is equal to 0. So let us consider this an equation. This is one equation, this is second equation, and again differentiating with respect to 2x, we get a plus b into y into d square y by dx square plus dy by dx into dy by dx is equal to 0. So this can also be written a is equal to minus b times of y into d square y by dx square plus dy by dx whole square, which is equal to 0. So we can make this an equation 3. So substitute a is equal to this expression in the second equation. So we get minus b into, or x times of minus b into y into d square y by dx square plus dy by dx whole square is equal to plus b into y into dy by dx is equal to 0. So now dividing b, you get minus x into y into d square y by dx square minus x into dy by dx whole square, and again here plus y into dy by dx is equal to 0. And here we can see that the highest order of this equation, order of the differential equation is 2. It's a second order derivative is there, and the power of the second order derivative is 1. So we can say the degree is 1. Order is 2 and degree is 1. So which is option second order and first degree is option D.